Hey all, good noon everyone. This is Mugilan from VCSE Scable. As the part of Smart India Hackathon 2024, we are here to present our idea for the problem statement of real-time disaster information aggregation software, and our problem statement code is SIH 1687 and our team ID is 126. So this software has been designed to save lives and losses with some advanced feature for the solution enhancement. And so now let's just dive deeper into what our solution exactly matches with the problem statement and what is the advanced feature that has been implemented for the solution for enhancement. So let's get started now.
Disaster response agencies often struggle to gather timely, accurate information from multiple sources like social media and news portals. It's overwhelming, and manually handling such data is inefficient. To solve this, we have developed a software solution that aggregates, categorizes, and presents the data on a clean, easy-to-use dashboard. This helps agencies make faster decisions and save lives. Our solution is powered by AI. It works by predicting and categorizing disaster data in real time, optimizing resource allocation, such as determining which rescue teams should be deployed first. While the app doesn't fully function offline, some critical features like maps and certain preloaded content will work in low or no network situations. Essentially, it's a comprehensive tool for effective disaster management. From a technical perspective, we are using custom AI models, specifically NLP and machine learning, to analyze and categorize data. Our software gathers information through APIs from sources like social media and news, then processes and categorizes it in real time. This ensures fast and accurate decision-making with multilingual support. Step 1. Request initiated. The request begins at the front end, which is built using frameworks like React, Next.js, or Flutter. The user interacts with the interface to request disaster-related data. The request is passed to the Django REST framework at the backend for processing. Step 2. Data fetching. The Django REST framework communicates with external sources, utilizing tools like Spacey and Hugging Face for fetching and processing data from social media, news platforms, and other relevant sources. The data is fetched through APIs like Twitter API, Xcon, and Google News. Step 3. Data collection from APIs. Information is gathered from external APIs like Google Maps and Google News. Selenium is used to scrape or interact with websites to gather additional disaster-related information. Step 4. Data processing. The gathered data is analyzed using machine learning (ML) models. This step involves determining the truth of the news data, converting it into a structured format, and passing it through NLP, natural language processing, models, primarily utilizing Hugging Face and TensorFlow. Step 5. Decision-making and categorizing. In this step, PyTorch is used for decision-making and data categorization. The ML models help with planning, data ordering, and categorizing the collected data for disaster response. Step 6. Backend processing. The processed data is sent back to the Django REST framework for further handling. The backend manages all the operations related to data categorization and decision-making. Step 7. Data storage in database. The processed and categorized data is stored in a PostgreSQL database. This database keeps all the disaster-related data, which is retrieved and sent to the frontend as required. Step 8. Data fetching from database. The data required by the user is fetched from the PostgreSQL database via the backend and REST API and sent to the frontend. Step 9. Processed data response. The processed data, which has been categorized and structured for disaster response, is sent back to the frontend. Step 10. Language translation multilingual support. The Hugging Face language translation feature is used to provide multilingual support. This ensures that users from different regions can access the disaster information in their preferred language. Feasibility-wise, this solution is totally viable. Technically, we are using cloud services, AI models, and scalable infrastructure that are well established. Economically, it's cost-effective with low initial costs, and it can generate revenue through subscriptions or consulting. We have ensured compliance with data privacy laws and ethical AI practices. While challenges like data accuracy exist, we have addressed them with strategies like strong encryption and regular updates. The impact is clear: Faster decision making in disaster scenarios saves lives. Our software sends timely alerts, optimizes resource use, and makes communities safer. It's cost efficient, helps reduce financial losses, supports eco-monitoring, and is incredibly easy to use, accessible anytime, anywhere, with partial offline capabilities for essential features. Finally, our research is backed by credible sources like the National Disaster Management Authority and the World Bank. We have used advanced AI tools like Hugging Face and TensorFlow to develop our solution, ensuring that it's built on solid research and real-world data.
So this is the end of the video, and I think this video will be the clear component that explains the process of the solution that we have made. And the main reason that we picked this problem statement is because of the recent heartbreaking incident that's been occurred in the Wayanadu near Kerala. So, and I hope young minds contribute for the society. Thank you, Team Smart India Hackathon, for this opportunity for these youngsters, and thank you all. So let's build a better future of India.